Today we're going to be covering some interesting examples using mean, median, and mode. It seems like a simple concept, yet its applications go far beyond the basics. By the way, if you haven't checked out the last video, be sure to check it out about special sequences and telescoping. So today we're going to talk about mean, median, mode, some cool examples. The mean is just the average of all terms, sum divided by number of terms. Let's take an example from the AMC. A finite set S has the following properties. The mean of S union 1 is 13 less than the mean of S. And the mean of S union 2001 is 27 more than the mean of S. Find the mean of S. So S is just a set. First of all, what does this U mean here? That actually means union. So what does union mean? Well, let's say we have these subsets 2, 3, 4, and 5. And another set 1, 2, and 3. So the union of these would just be all the terms that occur in either subset. So 1, 2 occurs in either subset, but we don't write it twice because it occurs in two subsets. Then 3, then 4, then 5. Because 3 also occurs 2 times, but we just write it once. So union in this case basically means that the subset S contains some elements. And we're adding another subset 1. So we're basically just adding another number 1 to the existing subset. Now, what if this original subset already had 1? Then if you take the union with 1, the subset would actually be unchanged. So how do we know this is not the case? Because the question states that this mean is 13 less. And if the set is unchanged, then the mean cannot also be must also be unchanged. So now let's take a look at this condition. How can we write it as an equation? Well, let's say these first n terms have an average value of x. So their average is x. Average equal to x. Now by adding another 1, now what is their new average? Well, if the original thing had n terms with the average of x, the new sum is nx plus 1. N times x, an additional 1, divided by n plus 1 terms. And this is equal to 13 less than the mean. Now, we also have the second condition. The mean of S union 2001 is 27 more than the mean of S. What does that mean? Well, now instead of 1, we're adding 2001. And like earlier, if the original subset already contained 2001, then the union would not change the set, because a set union of one of its elements is just the same set, because union is just all the elements combined. You don't write the element twice because it's in both sets. So, but if the set is unchanged, then the mean cannot be 27 more. So that's not possible. So we know that we're basically adding 2001 to the set now. So therefore, this would be nx plus 2001, right, divided by n plus 1. And this is x plus 27, right, because it's 27 more than the mean. And now we have two equations, and now we can just solve. But how are we going to solve this? Now you could expand, clear the denominators, and do some messy calculations, but the key thing to notice here is that this bottom term over here is very similar, except it just has an extra 2000 over n plus 1. It has an extra 2000 over n plus 1, right? Because the difference between this term and this term is just 2000 over n plus 1, since the denominators are the same and the nx's will just cancel out. So 2000 over n plus 1 is a difference. So we add x plus 27 minus x minus 13, 40. So this will be equal to 40, because this term is 40 more than this term, and this term is 2000 over n plus 1 more than this term over here. these must be equal because both of these equations are equal. We're just basically subtracting this equation from this equation. So what do we get from here? We have n plus 1 is 50, or n equals 49. So now we know the value of n. Now we just solve for x. And this isn't too hard. We have 49x plus 1 equal to 50, n plus 1 is 50, times x minus 13. Because you can move this to this side here. You get times n plus 1. Once you move this away, we're just left with nx plus 1 equals x minus 13 times n plus 1. And plugging in n, we get this equation over here. And now it's a one variable equation. It's not too hard. We write this as 50x minus 650, 49x plus 1, and now we subtract 49x from both sides. So 1 equals x minus 650. Add 650 to both sides to get x equals 651. Now this is one solution, but here's an even more clever solution that we can do. So the even more clever solution is to realize that S union 1 is 13 less than is 13 less. S union 2001 is 27 more. So what if there was some number such that S union, let's say k, is the same, 0? What if there's some number such that, let's say, it's not the union, let's say we add an element k to the subset S, and when we add that new element, the mean is still the same. Well, the key thing here is that by adding a different number from 1 to 2001, our mean is just going to be linear, because the mean function is a linear function. So what we can do here is see that the value of k such that this will be equal to the same mean is simply, well, we have what we see over here, nx plus some k divided by n plus 1 is equal to x. And let's solve this. Nx plus k equals nx plus x. So k equals x. So what we can see here is that in order to get a sum of the change of 0, all we needed to do was find this k. And this k will simply be 13 over 40 of the way from 1 to 2001. So 13 over 40 of the way from 1 to 2001. So once we find that point over here, that's just 13 over 40 times 2000 plus 1 equal to 13 over 40 times 2000, 650 plus 1 is 651. So that's this point over here. If k is 651, then this will just be 0. The mean will be unchanged. Now, because the reason we knew this is because we just took the value that's 13 over 40 in between these two values to get a value that was 0 over here, unchanged the mean, and not minus 13 or plus 27. Okay, so now you probably know that median is just the middle number, or average of two middle numbers if the number of terms is even, and the mode is the most common term. Now there's some other means, like geometric mean, for example. Now geometric mean is the nth root of the product of numbers. So we just take the product and then the nth root to get the geometric mean. Harmonic mean is 1 over the sum of 1 over all the numbers. So basically what we do is we take all the reciprocals and add them up, and then we average those reciprocals, and then we take the reciprocal again. To average the reciprocals, and then you take the reciprocal again. And it simplifies to this: the number of terms divided by the sum of the reciprocals. The quadratic mean is to get the quadratic mean, all you have to do is take the average of all the squares. So you take the average of all the squares divided by n, and then take the square root of that. Now let's take an example that uses median. What is the sum of all the real numbers for x for which the median of the numbers 4, 6, 8, 17, and x is the mean? So the key thing here is that let's calculate the mean in terms of x. The mean in terms of x is just 4 plus 6 plus 8 plus 17 plus x divided by 5, right? And this is 35. 4 plus 6 is 10. 10 plus 8 is 18. 18 plus 17, 35. 35 plus x over 5. Okay, so now we know what the mean is. What about the median? Well, the median really has a few choices here. Let's say our number x was really tiny. If our number x is really tiny, let's say it was here or something, then what would be the median? The median out of 5 numbers is just the third term when increased from lowest to highest. So if it's the third term, then it would be 6 in this case, if x is tiny. If x is very, very small, it would be 6, because there would be 2 terms to the left of 6, 4 and x. So when is 6 the median? Whenever x is less than or equal to 6. Why? Because if x is less than or equal to 6, then there's always going to be 2 terms on the left side of 6. So it will be the third term, and that will be the median. So if x less than or equal to 6, median equal to 6. But the question states the mean is equal to the median. So that therefore we have the mean for all numbers, and we can actually simplify this to 7 plus x over 5. We have 7 plus x over 5 equals 6. That means x over 5 is -1, x equals -5. Now, the key thing to check here is not always will this work. Is -5 satisfying this condition of x less than or equal to 6? Yes. Yes, so now we're good. X equals -5 is a solution. Now, but x is not always less than or equal to 6. What if x is a median? What if x is not less than 6? It's maybe more than 6, but less than 8. Well, if x is more than 6 and less than 8, then it will be the third term. Why? Because 4 and 6 are less than it, 8 and 17 are greater than it. So if x greater than or equal to 4, less than or equal to 6, then x is median. Now, you might be wondering why I put less than or equal to 6 in both of these cases. Well, the truth is, in 6 is kind of like the intersection point. In both of these cases, it has the same value, because when it's less than or equal to, when it's over here in the second case, it will have the same value, the median, because median is equal to x in this case. So when x is equal to 6, then these medians will be the same anyways. So I'm just going to include it as part of this case. I meant to say x is more than 6 and less than 8. So then the median will be x. So therefore we have 7 plus x over 5 equal to x. So what does that mean? That means that 7 is 4/5 x. X is 5/4 times 7 equals 35 over 4. That is 35 over 4 in this range. 35 over 4 is 8 3/4. Uh-oh, that's 8.75. Too big, so this solution does not work. Okay, now what about x is greater than or equal to 8? Well, if x is greater than or equal to 8, then it will be somewhere here or wherever else. It could be a million for all we care. So if let's say x is bigger than 8, then what will be the median in this case? Well, now there are 2 terms less than 8, 4 and 6, 2 terms more than 8, 17 and x. So therefore, 8 is the median if x is greater than or equal to 8. Median is equal to 8. So 7 plus x over 5 equals 8. X equals x over 5 equal to 1, x equals 5. Doesn't work. So the only solution that works is negative 5. That's the answer. To summarize, what we did is we looked at 3 cases in between 6 and 8, before and after, and then we just, from there, we just saw, compared what the median must be and solved the equation for each case, and always checked if it would satisfy the condition. That's it for this problem. Now we're taking a look at a problem that also involves one of the previous concepts we learned. When the mean and median mode of the list are arranged in increasing order, they form a non-constant arithmetic progression. What is the sum of all possible real values of x? This is interesting. So we've got now an arithmetic progression going on. That's strange. Okay, so first things first, when we have a list like this, a good strategy is always to put them in order. So let's put them in order. 2, 2, 2, 2, 2, 4, 5, 10, and then x, we don't know where it is because it's an unknown value. So first of all, do we know any of these quantities right off the bat? Well, the mode has to be equal to 2, no matter what. It has to be 2, because it appears 3 times. The mode equals 2. Now, what about the median? Well, the median, we don't know what that is because we don't know where x is. That will influence the median. Now, what about the mean? Well, the mean is just the sum divided by the number. There's 7 terms, as you can see here. 7 terms. The sum of all the terms is going to be 2 plus 2 plus 2, 6, plus 4, 10, plus 5, 15, plus 10, 25, plus x. So we have 25 plus x plus 7. So this is a mean, always, for every x. Now, the unknown is the median here. So what can we do to find the median? We should then take cases like we did earlier about where x is. And the key thing to know where to take cases from is to see that if x is very left, then the median will be the 4th term. It will always be the 4th term in this case because there's 7 terms. If x is very left or very small, then the median will be 2. If x is very big, then the 4th term will now be 4. So we know that the median can be 2, 4, or even x if x is in the middle of these two things. So those are generally the 3 cases we always consider. Case 1. The first case we have x less than or equal to 2. So if x is less than or equal to 2, then what is the median? Well, we just discussed this. It has to be 2, because now there's 3 terms to the left of 2. So 2 is the 4th term. The median is equal to 2. If x is greater than or equal to 2, but less than or equal to 4, what is the median now? Equal to x. Because now there's 3 2's that are less than it. There's 3 2's that are less than it, and 4, 5, 10, which is bigger. So median equal to x. Now what about if case 3? X is greater than or equal to 4. If x is greater than or equal to 4, then the median will just be 4. As you can see here, if x is here, then 4 is the 4th term, or the median. Median equals 4. And this is a standard pattern like we saw in the previous problem for finding median. So, but that's not what the question is saying. The question is saying form a non-constant, which means the common difference cannot be 0, arithmetic progression. So what do we do from here? Okay, let's take a look at this first case. If the median is equal to 2 and the mode is 2, then can it even form a non-constant arithmetic progression? To form an arithmetic progression that's not constant, we have to have something like a plus d, a plus 2d, where d is positive. But that means none of the terms can even be the same. So if these two terms are the same, then no matter what other value we choose, there will always be a common difference of 0, which is not allowed in an arithmetic progression. So this whole case does not work. 0 values that work. Now, what about the second case here? Median equals x. If median equals x, then maybe we do have a possibility here. 2x 25 plus x over 7. Now the thing here is, in increasing order they form an arithmetic progression. But we don't know the order of these three terms. We don't know, or do we actually? We know that x is greater than or equal to 2. So we know that 2 must be before x. But what about the order between x and 25 plus x over 7? Well, the key thing to notice here is that x, 25 plus x over 7, will actually have that x is less than 25 plus x over 7. The reason being, let's say we multiply by 7 to both sides. We get 7x is less than 25 plus x, or 6x is less than 25. But this is always true as long as x is less than or equal to 4, because 6x will never be 25 when x is less than or equal to 4. So therefore, this case, we had to have 25 plus x over 7 be the largest term. So now, to form an arithmetic progression, what must we have? Well, the sum of these outside terms must be equal to 2 times the middle term. So we have 14 over 7 plus 25 plus x over 7 equals 2x, or 39 plus x over 14 or over 7 equals 2x, or equals 14x, because we multiply by 7 to both sides. And we get x, 13x is 39, so x is 3. And this is in the range, so we're good. We found a value of x that works, 3. But this isn't our final answer, because we have one last case to check. If x is greater than or equal to 4, then the median has to be 4. So the mode is 2, the median is 4, and 25 plus x over 7, we don't know where it is yet. Well, first of all, 25 plus x over 7, we know x is greater than or equal to 4. So this must be at least 29 over 7. And 29 over 7 is bigger than 4. So we know that this will always be the largest term. So for this to be an arithmetic progression, what must we have? We must have 2 plus 25 plus x over 7 equals 2 times the middle term, 8. We subtract 2 from both sides. 25 plus x over 7 equals 6. So 25 plus x is 42, or x is 17. And 17 is bigger than 4, so we are good. 17 also works. Our total, we've exhausted all three cases. Our total is just 17 plus 3, which, using addition, is 20. By the way, this is a book with a bunch of practice problems you can check out. Link will be the top link in the description. Description below, top link. So now we're going to move on to some interesting systems of equations problems from AMC and many other places. We have some interesting problems that involve tricky word problems that we have to set up systems of equations for and then solve. We'll check that out all in the next video. You can check it out over here.